Another extremely important tool for the electrical and computer engineer is the multimeter. We call it a multimeter or a digital multimeter or a DMM because it can measure many different characteristics of a circuit. Now, ordinarily what you're going to find is that the multimeter will start in the off position. If you forget to turn it off, your multimeter will probably have a timer that will turn itself off, so that shouldn't be too bad. The multimeter can be used to measure many things, but it's important to notice that depending on what you're trying to measure, you may need to adjust where the things are plugged in the bottom. You'll notice over here this says V, omega, and a little diode symbol. We're not going to need the diode symbol so much, but the V stands for voltage and the omega stands for resistance. So for example, if I had a resistor, I have here a resistor of unknown value, and so I want to know, hey, how much is that resistance? Well, I'm going to go ahead and turn it to the omega range, and I don't really know how big it's going to be, so I'll initially set it to the 20 kilo ohm setting. Now I've got here the two probes that are attached. So those probes are attached to the multimeter, and I'm going to, let's just first of all test that the multimeter is working, because if I connect those together, I should get about 0 ohms, and that seems like it's giving about 0 ohms, so that's good. Now I'm going to go ahead and pinch this with each of my two thumbs. I'm going to put the resistance in between there, and I'm pinching pretty hard here to make sure that I'm making a pretty good connection, and I'm not getting anything. So that means that the resistance is more than 20 kilo ohms. Pinching again, not really getting anything, more than 200 kilo ohms. Oh, okay, so now I'm in the mega ohm region, so I'm at about 0.31 mega ohms, or about 320 kilo ohms. So that's a pretty large resistance. Let me try a smaller resistance here. I've got, this one I know is 1 kilo ohm, so I can crank this down to the 2 kilo ohm region, and then when I touch it on here, I should get right at 1.00 kilo ohms. And I'm very close. So this says that it's about 992 ohms. And of course, these resistors vary slightly by about 5% at most. And so 0.992 is very, very reasonable here. Now, we can also measure voltage on this setting. I've preset the multimeter, the power supply right behind here. I've preset it to an unknown voltage. Let's see now. There's actually two different voltage ranges here, but the little wavy line on top here says that this is AC voltage. What we want is DC voltage. So DC is what we're going to be working with, and so I'm going to go ahead and adjust this down to the 20 volt range, and then I'm going to go ahead and take the two micrograbbers. The ground goes to ground, and the red goes to red, and I'm finding that that's about 10.02 volts. And that agrees very favorably to the onboard reading, which is 10.01 or 10.00. So you can see that we've got here two different devices that are reading that same voltage to be very similar to each other. Another thing that I might want to measure is current. Now, to do current, I actually have to create a little circuit to allow current to flow. So that's why I have that little 1 kilo ohm resistor. You remember this 1 kilo ohm resistor? But remember that if we want to measure current, now I have to choose one of these two plugs. So the black will always stay in the same place, but the red, we're going to move that over to the milliamp current. If you forget to make this change, the multimeter is not going to do what it's supposed to do. So you've got to remember to make that change. Now what I want to do is I want to take the ground here, and I'm going to connect it to the ammeter. It's now an ammeter because I've got it measuring current. And if I were to connect this directly onto here, well then there would be no resistance, and then we would see how the overload light turns on. But what I'm going to do is I'm going to put this on this end, and then I'm just going to pinch this here with my thumb. And what I should find is that if I'm measuring DC amps, I'm getting about 10 milliamps flowing. 10 milliamps because I have 10 volts and a 1 kilo ohm resistor. 10 volts divided by 1 kilo ohm gives 10 milliamps. So I'm doing a good job of measuring the current there, and it's turning out to follow Ohm's law. You know, this in fact could just verify Ohm's law to a certain extent, but that's not enough for us. So that's how you would measure current. And don't forget, after you're done measuring current, you got to put the voltage back, or the red terminal back over there. And then the other thing that this one can do, it can measure characteristics of transistors and diodes, but we're really not at that point yet in the course. So we're not going to be using this part of the multimeter. But it can also measure capacitors, and this is a capacitor. You probably will see a capacitor later on this semester. And so if I put the range down here to F, that stands for farads. And farads, let's see, I happen to know from reading this one that this is a 100 microfarad capacitor. So I'm going to put it on the 200 microfarad range, and then I just poke it into these holes, and I think I poked it in backwards. So let's put it in the other way, and doesn't seem to be happy. Let's try it back the original way again. So I'm not sure why this isn't giving the correct result. Okay, there we go. I think it was just positional. I think that, actually, I think that my fingers were changing the capacitance. So once I take my hand off the capacitor, then we're getting right at 100 microfarads, which is just what the capacitor says. And let's experiment here. Okay, yep, as I adjust this, as I move my fingers in and out, it changes the capacitance. So that's a good thing to know. And if you get a reading that you want to remember, but you're afraid that it's going to change, you can always hit this hold button, and now the reading will not change no matter what I do. Even if I take this out or anything, that reading is going to remain unchanged, so you can put it into your notebook, and then once you take the hold button off, then it'll take care of itself. So that's the digital multimeter. It can be used to measure primarily resistance, voltage, current, and capacitance. And each one of those will be beneficial to you in certain labs.